So I'm going to be doing another rotating problem, and this time not only am I going to find the velocity, but I'm also going to find the acceleration using the general equations for motion of a rigid body. So it's giving us a few things. It's giving us, for the member shown, the angular velocity is counterclockwise, which means, again, that say we have some reference angle here, the W angular velocity is going that way, and we can note that this is going to be on the XY plane. Similarly, the angular acceleration will be going that direction, which means that if this is in the XY plane, that means the vector W is in the K direction, and the angular acceleration is also in the K direction. They are both, if we use the right hand rule and put the bottom part of our hand onto this paper and curl it towards the velocity and the acceleration, our thumb will be pointing outside of the page. So we could say that these vectors are outside of the page. Okay, so let's get to it. We want and they're giving us the acceleration, but we don't need to worry about that now. We're just going to focus on the velocity. It wants to find the velocity and the acceleration of point B. So here is our point of interest, point B. Okay, so we're going to start with the velocity equation. VB is equal to V of some point plus angular velocity across the position of B relative to some point plus the relative velocity. And how do we choose that point? Well, like I said before, we can look at B move at any point, but what we do know is at point A is connected to the ground with the pin. So is not position A 0? The velocity is 0, right? Because it's not moving. It's bounded to something. So we know that the velocity at A is equal to 0, so why not just choose A as our point? So now we're looking at B move from this position right here. We're observing B move. Okay, again, there's a couple things that'll make this equation a lot simpler, and one is that since we chose point A and point B are both on one body, that means that the relative velocity is equal to 0. And we just said that at point A is connected to the ground, so that has 0 velocity. So now we can conclude that the velocity at B is equal to the angular velocity cross the position vector B relative to A. So all we have to do is find these two vectors. So vector, the angular velocity, we know is going counterclockwise at 10 radians per second counterclockwise. So we could say that this is the magnitude of W is 10. And what is the direction of W? Well, we just said the direction of W is outside of the page, which is positive K. Okay? So now let's find the position of B relative to A. Now remember, since we're observing B's motion relative to A, we're going to start at point A and we're going to fire off a vector straight to position B. Okay? And so how are we going to get to position B? Well, if this is the X, this is the Y, we're gonna walk along here on the X-axis. We'll drop a perpendicular line that creates a 90-degree angle. And we can see that this angle right here would be 90 minus 25. So we could say that position B and this moment, this arm is 3 inches. So in the X direction, we could say that this X vector would be R cosine theta, which is 3 inches times cosine of 90 minus 25. So 90 minus 20 is 70, minus 5 is 65 in the I direction. And that's going to be positive. And let's see what it's doing in the Y direction. Y direction is going to be positive as well. And we're going to go up here just like that. And so this would be R, which is 3 inches, sine 65 degrees, and there is no K component. Okay, looks good. So now we just have to do the cross product or the determinant of I, J, K. This would be the W, P, with respect to A. So this would be 0, 0, 10. 3 cosine 65. Looks like we're gonna need a little bit more room here. Okay, let's see if that will be enough room. So this will be 3 sine 65 and 0. Looks good. This is V relative to B. So we can conclude that V relative, or V, the velocity of B. Again, I'm going to use my calculator. So let's see, 3 cosine is 65, 3 sine 65, 0. I'm gonna do a cross product. We will get negative 27.2, the I direction, plus 12.7 in the J direction, and 0 in the K direction. Okay. So this is the velocity.